So now you're going to go ahead and take out your worksheet that you have for this. And for each of these problems, we're going to answer the question that's stated. Then we're going to state the constant, or in other words, solve for k. And we're going to write the equation substituting in for k. So I know this is kind of small on your screen, but you have the worksheet so that it looks a little bit bigger. So it says y varies directly as x. So they're just telling us it's a direct variation. If x is equal to 5 and y is equal to 12, find x when y is 30. So we're going to set up a proportion. Now, I like to do proportions with the first bits of information as my first fraction. That's not the only way to do it. You could do x equals y or 5 equals 12. I'm going to set those two up as a fraction of 5 over 12. And that's where my top number was x and my bottom number was y. Now, probably a better idea to reverse those, but if you set it up this way, you'll still be able to go through and solve for your x and y. But usually we're used to having, when we do slope, our rise over our run. But we can go ahead and set it up this way. Okay, the third bit of information says find x when y is 30. So if our y is 30, well, on my bottom is where I had the y's. So now we're going to go ahead, cross multiply, divide to find out what our x would be. So 30, and this is reviewing stuff that we've done previously, 30 times 5 is going to give me 150. And then 150 divided by 12. So divide by the third gives me 12.5. Okay, so I just found out that x equals 12.5, so that's solving the first problem. The next thing is they want us to solve for the constant, or the k, by filling in our known x and y and solving for k. So I'm going to use the original statement here and substitute in. So our original equation, I'm going to write right below here, is y equals kx. Okay, so we're going to go ahead and we have to solve for our k. So we're going to substitute in, well, y was 12 equals, we don't know k, but we know that x was 5. Now, if I want to work to get k by itself, we'll divide by 5. Divide by 5. K equals 12 divided by 5 is 2.4. Okay, so there's the second one, solving for k. And then the third box asks us to write that equation. So we're going to substitute in our 2.4 where k is in the equation. We're going to leave y and x as they are. So y equals, our k is 2.4 times x. Okay, and this is what we would be using if they wanted us to graph out that equation. We could go through and pick different x's and solve for y. But we know that it is directly varying by 2.4 every single time we have a different x. Okay, so number 2, it says Heather's weekly pay is directly proportional to the number of hours that she works at the record store. Her pay, which we're going to use for y, is $174 for 24 hours x of work. So $174 for x, which would be her work hours, 24 hours. And I'm just putting the label off to the side. Find the amount of pay that she gets for 40 hours of work. So our second bit, or our third bit of information is 40 hours of work. So now we'll go ahead and cross multiply, divide. So 40 times 174, and obviously this isn't the only way to solve it, but I wanted you to work proportions, reviewing what we've learned previously. So 40 times 174, and divide that by 24, gives us $290. So she's going to get $290 for that 40-hour week. The next part, solve for the constant k by filling in the known x and y. So I like to use the one where they've already given me that, just in case I made a mistake in my proportion answer. I shouldn't get the second one wrong if I use the information that they gave us. Okay, so y was 174. So remember, we're going to use this equation, 174 equals, we don't know k, but the x was 24 hours. Okay, so now we're going to work to get k by itself. So divide by 24. Divide by 24. We get k equals 174 divided by 24 gives us $7.25. So in other words, she's getting $7.25 an hour. Okay, that's our rate also. And we could have also gotten that here. You'll notice that that's what I ended up doing, is finding the slope or the rate. In our third box, we're going to go ahead and substitute in. So y equals, our k was $7.25. And then we would substitute in for x. So for example, why would we ever use this? Well, maybe I want to find out how much she would get for a 50-hour week. So then I could figure out her y is her pay equals $7.25 times 50 hours. So I could punch in 725 times 50 and find out that she's going to get $362.50 if she works a 50-hour week. Okay, so that's where you're going to be using that direct variation equation, is sometimes they're going to have you actually plot out. Okay, so let's do one more. It says, Eduardo counted 10 seconds between seeing lightning and hearing thunder, and he knew that the lightning was 2 miles away. Okay, so we went ahead and did our 10 seconds, and I'm actually going to jump to my next slide just so you can see what we're going to be doing. So this is the same thing, I just didn't put my y's and my x's in the number 3 like you have. So here I said 10 seconds, this was our y. And then between hearing lightning and thunder, and he knew that lightning was 2 miles away, so this was our x, was our 2 miles. Okay, so our y is 10 seconds, so I'm going to do y over x. So 10 seconds over 2 miles. Okay, the third bit of information, if he counted for 4 seconds between the next flash of lightning and thunder, about how far away was that? So our seconds we had as our top number, so we're going to put 4 as our top. Now we'll cross multiply divide, so 4 times 2 would give us 8 divided by 10. So 8 divided by 10 is going to give me 0.8 or 8/10 of a mile. Okay, so now we're going to solve for our constant. So I'm going to use my original x's and y's, which were right here, and substitute in. So my y was 10 equals our constant, which we don't know, times our x, which is 2. Just using that. So then to solve for k, we'll divide by 2, divide by 2. I find out that k equals 10 divided by 2, which is 5. So our constant is 5. So our variation is it's going to be times 5 every single time. So y equals k is 5 times x. So now if I wanted to substitute in and figure out if I said it was 20 seconds away, I could substitute in 20 here, where y is, because that was my seconds, equals 5x, and then I could divide by 5, and find out that it's actually 4 miles away. Okay, so that's kind of where we would go through and do that. So now what we're going to do is we're going to go ahead and pick some different x's and y's. So we just found out that our k, this is the equation right here that we're going to use up here. So if you want to use this as one of your graphs on the back side of your worksheet, you can. So we've got y equals 5 times our x, and we're going to substitute in for our x. So 5 Okay, so maybe for our x's, we could do, I don't know, because our x's were our miles, right? So let's just do 1, 2, 3, 4, 5. So we'll do 0, obviously. Then we'll do a 1. We'll substitute in a 2, a 3, and a 4. So our x's are 0, 1, 2, 3, and 4. And then to solve for y, we're just going to solve this answer. So y equals 5 times 0, which is 0. So 0, comma 0. And then y equals 5 times 1, which is 5. So 1, comma 5. Y equals 5 times 2, which is 10. 2, comma 10. And then 5 times 3 is 15. So 3, comma 15. And then 5 times 4 is 20. So 4, comma 20. So now we're going to set up our graph. So our graph, well, our x's, these are always our x's, and that was our miles. And our y's, and I'm just pulling this information here, and I have it marked in your thing, is our seconds. And then we have to decide what we want each box to be worth. So for our miles, it looks like our x's went 0 through 4, so we could make each of these worth a box. Each box worth 1. So 0, 1, 2, 3, 4. And if you wanted to skip every other box, you could do that also. And then for our y's, it looks like we have to get up to 20. So let's see, 2, 4, 6, 8, 10. I think we could go every box is worth 1. I'm just going to mark every other one. So 2, 4, 6, 8, 10, 12, 14, 16, 18. I'm going to have to go slightly off. 20, we're going to have to jump. We're going to have to go slightly off. So now if I go over to 0, up to 0, and I'm just plotting these, over to 1, up to 5, so there's 5. Over to 2, up to 10. Over to 3, up to 15. And over to 4, up to 20, which is up here. So you'll notice that we have a nice straight line. And that's graphing it. So here we could title this maybe lightning versus thunder. Because we're talking about how many miles away the lightning would be when according to the number of seconds of the thunder. Okay, so that's working with graphing our y-intercept equation, our direct variation equation. That's it. So the key thing to remember here is in order for you to have direct variation, it must have a straight line and it must cross through 0, 0. So when you're doing your second graph, make sure that you identify one of your numbers as 0, 0.